All right, so today what we're going to try to do is we're going to try to discuss the similarities and differences between osmosis and diffusion, and then when we get done with that, we're going to actually set up a lab where we're going to use an egg or a cell, an animal cell, and set up in different solutions and see how the movement of molecules happens, or what happens between the movement of molecules there. Okay, so what we need to know is that the cell membrane, what do we know about the cell membrane so far anyway? What's it made up of? What's the cell membrane?
Phospholipid bilayer.
Phospholipid bilayer, okay. So what's that made up of? You said one of them.
Fatty acid tail.
Fatty acid tails and
Phosphates.
Phosphates, has protein channels also, right? So there's all these different parts. So we know that some things are able to pass through the cell membrane, don't we? Okay, they're easily passed through the cell membrane. What do we call the cell membrane? It's selectively what? Say it louder.
Permeable.
Permeable. It's selectively permeable, right? So what does that mean? What's permeable mean?
It allows things to go through.
It allows some things to pass through the cell membrane. Okay. Other term that we're going to look at is diffusion. So what do we know about diffusion? It always goes from what to what?
High to low.
High to low. Does it require any energy?
No.
No. So some of those particles are able to pass right through the cell membrane because they're small and they don't have a charge, right? Okay, because if they had a charge, that would conflict with the fatty acid nonpolar region, right? Okay. And they pass through, they're going from high concentration to low concentration, or they tend to flow that direction, and then once you reach what? What are they trying to reach? They're trying to reach what term?
Equilibrium.
Say that louder.
Equilibrium.
Oh, right there. Equilibrium, right. Good.
Travis.
Okay. So, what we're going to look at today is osmosis a little bit more. Okay, so we know that some things can pass through the cell membrane pretty easily, right? Okay, they're small, they don't have a charge. What if something's really big? Can it pass through?
No.
So how do you get to, if you're talking about what a cell is in, okay, the liquid that a cell would be in, how do you get equilibrium? How do you reach equilibrium? So you have to we're talking about concentrations, right?
Equal.
So here, the red molecules are something that's too large to pass through the cell membrane, right? On the inside, we have the white, and I think that is going to be water. Okay, so we're going to pretend that that's water. So can the water pass through the cell membrane?
Yeah.
But the red cannot. So if water can pass through, can we dilute it or change the concentration of the red?
Yeah.
Yeah, so here we're diluting it, right? Now we have changed the concentrations. Okay? So now we have a different concentration over here than we did before, right? Okay? So the same thing works in your cell. Water can pass through the cell membrane, but larger molecules cannot. Okay, so what I've done, and I've set this up here, we'll see what it looks like after tomorrow. On the right side, I have put sugar water. Okay, and on the left side, I have just regular water. Okay? So what do we think will happen? Okay, is sugar going to be able to pass through this selectively permeable membrane I put in here? No. What about the water?
Yeah.
The water can pass through. Okay, so which direction is the water going to? Which one's going to be higher? The one on the right or the one on the left?
Left.
So that means that there's water. That water is going to leave the sugar solution and go over to the regular water.
No.
So think about this. What's my concentration of water on the left side?
Low.
High.
It's all water, isn't it?
Oh.
So my concentration is high over here. And then I have sugar water over here. So is it lower than 100%?
Yeah.
Yeah, so the water's going to flow left to right. So this should be higher over here, shouldn't it? So we'll see if that works before tomorrow. Okay? So here's two examples of how water flows across the membrane in order to change the concentration or to reach that equilibrium. So we're talking about, with osmosis, we're talking about the movement of just water, right? Because the other particles cannot flow through. So on the board, I have three terms that you're gonna talk about today or learn about today. You have an isotonic. These are all types of solutions that you can put a cell in. You have isotonic solution, hypotonic solution, hypertonic solutions. Okay, so this happens in your cell all the time. If you have an isotonic solution, that means that the flow of water in the cell is equal back and forth. So the cell remains the same size. Does that make sense, everybody? Okay. The hypotonic solution means that you have a higher concentration of water outside than inside the cell. So which direction is water going to flow? Higher concentration out than in. So which direction is the water going to flow? In. So what does that cause the cell to do, you think, if you have a lot of water going in?
Expand.
Yeah, the cell will swell and expand. Good. Okay, then you have hypertonic. So hypertonic would be when you have a higher concentration of water inside the cell than outside the cell. So where's your water going to go now? Out. What's it going to cause the cell to do? Shrink. Okay, good. So that's what you guys are going to look at today in this handout.